We're moving on to experiment 2, which is the deflection of a simply supported beam. We have basically pivot points upon which the beam is resting loose. So it's effectively a pin support, and we will load it in the middle and observe how it deflects under that load. The support points are 400 millimeters apart. The gauge is in the middle, is 200 millimeters from either end. And we will zero that and then go through and load it. We'll be working with the aluminum beam because that with the lowest elastic modulus, it gives us the best visibility for the deflection. So we'll zero our gauge. And we'll start adding load, recording that our actual deflection is 0. So we put 100 grams on it. And have a deflection of 0.5 millimeters, 0.50 millimeters. Go to a 100 gram or 200 gram load. 0.94 millimeters deflection. (300), 1.41. So the deflection is moving, it's increasing linearly as we go up and load. At 400, we're at 1.90. At 500, 2.38. So generally, there are a little bit of variation in it, but this would be more of a random variation. It's moving linearly as we increase the load. So that's the first part of experiment 2. The second part, we want to change the horizontal distance and take the same measurement with the 500 gram weight and look at how that changes with the effective length. So we're going to load it.
Well, start with explaining that you moved those in.
We've moved the distance between our support points to be 100 millimeters on either side of the center, which is where we're measuring. So we have a 200 millimeter wide gap, or a 200 millimeter simply supported beam. And if we load that with 500 grams, our deflection will be 0.34 millimeters. Okay, so when we load that, we get 0.76 millimeters. And my data becomes 1.27 millimeters. take it up to 380. So I want to be 190 all three inputs, so I want to be at 110. And when I load it, my deflection will be 2.11 millimeters. And put a load on it. .19 millimeters. So we're supported 550 millimeters apart. Clear our gauge. And add our load. .62 millimeters. Add my load. And my deflected dimension, 6.55 millimeters. So when we plot these, we should see something on the order of a second degree curve or a parabola.